Hello everyone, welcome back to another calculus video. Now, this is a problem that we covered at the very beginning of today's lecture in my Calc BC class, and we just didn't have enough time to do it. The problem took longer than I anticipated. I didn't want to sacrifice too much class time doing something like this, especially since it wasn't the focus of today's lecture. So I decided just to make a separate video giving a complete solution to how to solve something like this. That way you guys can see how it's done and we don't have to eat up way too much of our limited class time. So what makes this one particularly complicated is the fact that at first it doesn't even really look all that clear what we're supposed to do. We don't have any particular tricks from elementary integrals that would help us with this one. For example, we know right away that if we want to integrate the natural log function, we're going to need to do integration by parts to some capacity. But the problem with that is we have a function on the inside. So if we had just natural log of x dx, we know exactly how to do this. We would just set natural log of x to be u, we would set dx to be dv, and then we would just continue this using integration by parts the way we normally would, and we would get x times natural log of x minus x. The problem occurs with this one when we realize that we have something other than x as the input of the natural log function, which makes things a little more complicated. Now, this isn't something that we've covered in any of my classes. This is a fairly new topic, but it is required to solve something like this. We're going to do things the way we normally do. We're going to use integration by parts. We're going to transform this from an expression involving x into an expression involving u, involving v, but then we're even going to have a third variable, and we call this third variable a parameter. So we're going to call our third variable t. T is going to be our parameter. And we're going to parametrize this. And I'll show you exactly what I mean by all that in just a second. But before we even apply integration by parts, we're going to need to do not u substitution, because u is already being used as a variable in integration by parts. We're going to use our new parameter t, and we're going to do a t substitution before we even get into the integration by parts. So we're going to set t equal to the entire inner function, 2x plus 1. And then we're going to take the derivative of t, dt, with respect to x, derivative of t with respect to x gets us just 2. So then dt is equal to 2 times dx. It's convenient if we had a 2 in there somewhere, but we actually don't have a 2, so we can't do that. What we want to do instead is we want to divide both sides by 2, so we're going to get 1/2 dt equals dx. And that makes things a little more manageable. So let's go ahead and rewrite this integral. We're going to have 1/2 the integral of natural log of t. We're going to have the natural log of our parameter t. T is our parameter in this case. So now that we have this parametrized, written this in terms of our parameter, now is when we want to use integration by parts. Let me move this aside, give us a little bit more room to work. Over there would be good. So we're going to decide what should be u and what should be dv. So as we remember from when we're first learning how to do very basic integration by parts, it's never a good idea to have the natural log function be dv. We always want the natural log function to be u. So we're going to set natural log of t to be u, which means that whatever is left, this dt is going to have to be dv. That's going to have to be u. So, dt is actually going to be dv in this case. So the first thing we want to do here is just rewrite this in terms of integration by parts technique. So we have 1/2, and then we have, this is going to be u, this is going to be dv. U is natural log of t, du is going to be dt over t, and then that leaves dv to be dt, and then v is going to be the antiderivative, so that would just be t. So when we're doing integration by parts, we're going to have u times v as we always do, so that's going to be 1/2 times uv, natural log of t times t, and then we have minus the integral of v times du. And it works really nicely because if we can see that in this integral right here, we have a t on top, we have a t on the bottom, and they cancel each other out. So let's go ahead and distribute the 1/2. We're going to have t over 2 times the natural log of t minus 1/2 integral of just dt when the t's go away. So this is pretty simple to integrate. We know exactly what to do here. The dt is just going to turn into a t when we integrate. All right, so we're done with the actual calculus part, but this is not the final answer. We're not finished quite yet. The only thing left to do would be to substitute our parameter t back in. So remember at the very beginning of this problem, we set t equal to 2x plus 1. We put a parameter t in terms of x. So now we want to deparameterize, which means to put things in terms of x instead of in terms of this parameter. So our solution is going to be t over 2. So that would be x squared plus 1 over 2 times the natural log of t, so natural log of 2x plus 1, minus 1/2 of t, so minus 1/2 of 2x plus 1 plus c. And this is our complete solution. This is the antiderivative of natural log of 2x plus 1. It was kind of new, kind of complicated. I've never gone into anything like this in any of my previous classes. We've never really talked about parameterization all that much, but I always thought this was kind of an interesting problem, and this is how we deal with something like this.